Good evening, ladies and gentlemen. Welcome to your Taylor Tutors Chemistry evening this week. My name's Rich, a different Rich to yesterday because he's the biologist and I am the chemist. So a little confusing maybe. Paulie, how are we doing? Were you here last night, mate? Here we got Uzwa, we got Ryan. How are we doing, folks? We all start this week. We all back in school or back in college this week. How's it all going so far? Just a bit of chit chat just before we get going on here. There's a bit of a delay, so I'm waiting for you guys to type something for me. So what's tonight all about? We are looking at chemistry. We're looking at your first year or your second year in chemistry, depending on obviously where you're headed at. So Sarah, you're back on Friday. That's a funny day to go back in. Who wants to start on a Friday? That's no good. We are, looking at we're looking at year 12, okay, and what sort of hints and tips I can give you to expect from your first year in A-level chemistry. And of course, if you're going into year 13, there's a few little snippets I can help you out with there as well, because of course, you know that you got lots of extra content going on in year 13. So Ryan just started today. How was your first day, pal? Paulie's starting tomorrow. Everyone's starting quite late in the week. I thought it was just like Monday kicks off and everyone's in. Apparently not. Well, I'm in Wales, so things are a little bit different here. Maybe can be a little bit backwards. You know, the rumors are true. But there we go. So, like I said, tonight is all about chemistry. So, anybody go and look at the biology webinar that we had last night with Rich? Don't be afraid to just type, yeah, whatever, okay? Want lots of interaction tonight, folks. I want you asking lots of questions. I'm sure you've got lots of questions about A-level chemistry and what to expect. Yeah, Mo, is it? Yes, I can give you some tips about starting at A-level chemistry. That is exactly why I'm here. That is the whole reason for me being for the next hour, okay? So I'm here to help you with your A-level chemistry and starting in year 12, or in fact going on into year 13. But you know what? I'm here from Taylor Tutors. So my other job tonight is to show you guys what we're all about, okay, and how we can help you right throughout the year with your A-level chemistry. And of course, biology and maths we do as well. So Rich and Ronnie aren't with us yet, but hopefully they will be joining us at some point. Okay, so yes, we are going to look at some chemistry. So I am going to screen share with you now, and I will show you exactly what it is we are going to be doing. Okay, so see if I can share my desktop with you guys, and hopefully everyone can see that. Everyone see the desktop okay there, folks? I'm going to leave that chat up there just so I can see exactly what you guys are saying. Okay, so starting your year right, all right, because you know what, for year 12 or year 13, this is what we're here to do. Make sure you get a good start with your A-level chemistry, because you know what, if you fall behind, it's really hard to actually catch up. So what are we covering tonight, folks? We are looking at what is Taylor Tutors all about for a kickoff, because that's where I'm from, okay? Myself, Rich, and Ronnie, all the R's, we're here to help you through your A-level chemistry, biology, and maths. We're going to be taking a look at what we offer in terms of the starter guide and the ultimate guide in chemistry. So essentially what you get, you know, if you join us on this journey through your A-levels this year, then how are we actually going to help you? And then we're going to look at my top tips for year 12 chemistry, and of course, moving on into year 13. And we're just going to have complete open house in terms of questions as well. We just got Rich joined us. How you doing, bud?
Let me unmute myself and say hello. Yeah, I got stuck with vehicles, but I am here and I'll jump on the chat, Rich. So on the YouTube, I can handle any of the comments on there, and I'll relay anything to you if I think it needs your attention.
Awesome. Cheers, mate. Right, so this is what we're doing tonight, folks. So first of all, like I said, what is Tailored Tutors all about? I suppose you should ask, have we got any current subscribers to Tailored Tutors in here tonight already? It's a bit funny, the delay on this.
Yeah, there is a little bit of a delay. It's a little bit hard. We ask our questions and it takes a few seconds for it to get to YouTube. So you guys might be answering super quickly.
Then yeah, we're waiting. So hey, we'll crack on anyway. So what's Tailored Tutors all about? And I'm pretty sure I've summarized this. You know, it's only like 6 points here. That's not many, but you know what? We'll do so much. So if you decide to join us on this journey this year, then we're providing exam-specific video tutorials. Now, they're 24/7. They're all on our website. Once you subscribe, you get access to those whenever you want. If 3 o'clock in the morning, revising and learning stuff at 3 o'clock in the morning floats your boat, that's exactly what you can do. Can't guarantee we'll reply to any comments at that point, but you can watch the tutorials. So we can provide, as I said, comments. We provide your support. So if you subscribe to the Ultimate Package, you can comment under every single video that we do, and we will get back to you. Okay, it won't be instant. We don't just sit here waiting on bated breath, but we will get back to you within, say, I don't know, 36, 48 hours maximum. So we're always there to answer any questions you've got on there. So Zim, yeah, this is a paid course, buddy, but you can subscribe for free this month. So I'll go more into that later. So what else do? We provide practice questions and answers as well. So right throughout the course, what we can do is, we put a load of PDFs in there. We've written a load of questions based on exams. Okay, so not just exam questions. We're giving you a load more questions to have a go at, as well as all the past papers. What we do, speaking of exams, is help you with exam technique, because knowing your stuff is one thing, but knowing how to answer the questions in an exam is another skill entirely. Now, I'm not entirely sure how much teachers in schools and colleges do of this. You know, a lot of their time, a lot of your time is spent just getting through the material. Like, you need to know this, you need to know that. What we do is help you answer the exam. So yes, we're here to provide content, but we're also here, which is just as equally important, to actually help you answer those exam questions. You know, between myself, Rich, and Ronnie, we've probably done thousands of exam papers in maths, chemistry, and biology, and we know these inside out. So we know what the common questions are. We know what keywords you need to use. We know how to pick those larger questions apart and help you answer them in, you know, a really concise way, so you don't spend hours writing out loads and loads of stuff for, you know, just for 4 marks. Okay. What else we do? Weekly web classes. So again, if you're subscribing to the Ultimate Guide, we will be here from the beginning of October right through Christmas up until the beginning of March, once a week, to do a year 1 and a year 2 tutorial. And that's Wednesday nights for chemistry. So I'll be on every single week on a particular topic, and we set you questions. You have a go at them. We review all those questions and those topics during those web classes. And then when we hit March, we're into revision mode. Okay, March, you think is, oh, it's months before the exams. It's never too early to start revising. Okay, so that's exactly what we're going to do come March, when our regular weekly web classes finish up. Okay, so that is what we do. So let me just show you actually what the difference is, because like I said, I keep talking about subscriptions. There are a couple of subscriptions you could get. So this summarizes them in a nutshell, and I'll show you what I mean in a second when we have a look at the website. Okay, so we got 2 for you to have a look at. Okay, we got a starter guide, and we've got our ultimate guide, which we're really proud of. Okay, so our starter guide, you can access video tutorials on all the topics. You've got the whole course there. Okay, you can access, and like I said, 24/7 access, and it's all exam board specific. Now, if you're in year 12, you get a discount. You only need to know half the stuff at that point. So if you're in year 12, you can subscribe. It's 19 quid a month, and year 13 is 29. You're getting twice as much stuff effectively. You need to know twice as much stuff, don't you? So it is a monthly subscription, but right now you can sign up for nothing. Okay, you can sign up for nothing using our coupon code TRYITFREE. So all capital letters, try it free, all one word, and you can just subscribe for nothing. You get your first month for nothing, and then of course, obviously, it's a subscription after that. Well, that's the starter guide, but the ultimate guide. This is what we're really, really proud of, okay? Because there's loads of extra stuff in here. This is what really sets us apart from your textbooks, other online providers, like just YouTube channels and stuff like that. This is what we'll do for you. You get everything, obviously, that you get in the starter guide, but okay, you can ask questions anytime you like. You pop a question underneath the video you're watching, even if it's just on a related question you maybe had for a homework. Take a snapshot and we can take a look at it, okay? We're not here to do your homework, but if it's an interesting enough question, we think it'll benefit everybody, we'll take a look at it. You get your PDF template notes as well. We've provided a load of templates for you guys to have a look at and to help you make your notes from the videos. You get those live weekly web classes too. All right. So like I said, there's like 22 of those between October and March. But of course, we're here all September as well to help you guys. But we've put together a past paper library too. So loads and loads of past papers there going back to, I know the chemistry ones, they go back to, I don't know, 2005, I think, or something like that, 2004. So there's loads and loads and loads to go at, and you get access to all the exam boards, past papers that we've collated for you guys, okay? So that's the starter guide and ultimate guide. Let me get rid of this. Let me just show you the website and what it looks like once you actually get in, and then we'll start talking about chemistry specifically. So I'll just open this up. So this is our website, okay? And obviously just have a look around in here. We've got the subscriptions, and you can look at the different ones I've just been talking about. And we've got some free resources. We sign up schools to the Brainier program and so on and so forth. But what we're interested in is this. So when you're a subscriber, this is what you see. So I've just got like a demo one here. This mystery student signed up to AQA Year 2 chemistry. So they're on the AQA exam board. And like I said, what you get here, we get all our live weekly web classes, okay, and your past paper library in here as well. Starter subscribers won't see these, okay? As an ultimate subscriber, you will. So you can see what we've got planned out all the way through the year. Year 1 and Year 2 live web classes, okay? And we're starting on the 3rd of October, Wednesday the 3rd of October in Chem. And I'm basically just going to be doing open questions. What have you done so far? You know, what have you covered so far in Year 12 and Year 13? Is there anything you're worried about? And basically, I'm just here to answer questions. But then it gets really structured. We're working through Year 1 and Year 2 stuff. So if you're a Year 2 student, you come along to all the Year 1 ones as well. They're between 6 and 7. Year 2 between 7 and 8 on a Wednesday. So a 2-hour stint. And we cover everything, essentially, right through. So it's basically live tuition. And you can ask questions, okay? We'll be taking polls. I'll be putting exam questions up for you guys to have a go at. So it's really interactive. It's not just me sat here talking, just like you're doing now on YouTube. You can ask questions, and I will answer them. So that's from October, like I said, right through to the 6th of March there, folks, okay? So let me just go back and show you real quick. So we got our Year 1 chemistry AQA. So these are all the lectures here, all the tutorials. So I don't know. Well, first of all, specification, really, really important. Okay, so this is the AQA spec here for you to download. You've got to have the most recent one. Okay, so you can download a digital copy of that and you can search through it. And you know what? They're not a great read, but they're not meant for you guys, really. They're meant for teachers, and they need to interpret it and teach it to you, which is why we've done this down the left-hand side here. These are all the topics in AQA chemistry. Obviously, if you're doing OCR or AQA, or Edexcel, it's going to be set up slightly differently. There's slightly different specifications, so it will be slightly different setup there, okay? So if I just click on one on the left here, this is relative mass and amount of substance, and we've got a sub-menu here, okay, of all the different subtopics that talk about moles and solutions, moles and mass, moles and gases, relative mass, and then you've got another submenu, and you've got your lectures down here. You've got your tutorials. So I've done an introduction for each one. So me just waxing lyrical, that's not a good look, really, is it? Just giving you an insight into what is actually in this section, okay? So we'll go back into relative mass, and we'll look at relative atomic mass, just for giggles. So this is what you'll see. You see the video, that'll pop up, and you can play it, you can pause it, you can rewind it, you can watch it 100 times if you want. And this is an example of these template notes that we've got, which we really, really like. So rather than you writing every single last thing out here, we've basically given you a skeleton structure, and you can just fill in the blanks as I go through the tutorial. So, you know, you can watch it through first time. That's what we recommend. Then go back, watch it again, and then pause and make your notes. All right. And if you think of any questions while you're doing it, straight away, you can just click down the bottom here and you can leave a comment. You can ask a question. Okay. They're called comments, but essentially it's where you ask your questions, folks. Okay. So that's our course setup. I tell you what, let's have a look at, let's have a look at another video here. Let's do, I don't know, atomic structure, ionization energies. This is a good topic. And ionization energies down a group. So this is how we've organized the entire course, folks. Okay, it's the same in biology as well, because that's more like chemistry, I suppose. Maths is a little different, but what we've done here, we use a color system. It helps you remember stuff. Okay, all the titles in blue, all the key terms in red. So you can see this explanation I've got over here. If I just fast forward, actually, I'll play this. Still and pause it there. Okay, that's basically the whole thing. Now, we don't recommend you do that. Okay, because there's explanations and there's little hints and tips that I give that I don't necessarily write down, which you can write down on your notes. But this here, you see all these key terms in red. These are all the key terms that you get marks for when answering a question on this in an exam. So, you know, this, we don't just give you stock answers, okay, even though this is a pretty good example of a stock answer. But these words here, these are the ones that you need to use if you're going to get the marks in the exam. I mean, how many times have you answered an exam question and think, yeah, I'm pretty happy with that, but you don't get as many marks as you think. In science, in particular, it's all about these key terms, okay? For biology and chemistry, it's all about these key terms. And obviously, if you put them in the right context, you're laughing all the way to the bank. It's full marks every single time, okay? So this is just an example of how we use these keywords and highlight them for you guys to use in exam questions. And down here, I'm saying, you know, these are the common questions. These are the typical ways they ask this question in an exam. So we're giving you an insight as to what to expect in the summer. We're not just giving you the content like a textbook and just say, yeah, crack on. You've got everything you need now, learn it yourself. We don't do that. We actually guide you through the exams and focus on exam technique. It's really, really, really important. Can't stress that enough. How are we doing on the questions? Rich, I can't actually see, bud.
We are doing good. Did I mute myself? Let me just check that I'm not talking to nobody. No, I am live. So Sebastian actually just asked a question for some chemistry stuff towards the end about he's about to start year 12 chemistry this week, I think tomorrow he said, and his question was about the delta positive, delta negative. Let me just find the question again. I still haven't started chemistry. The first lesson is tomorrow. Can you go through delta negative or delta positive or something like that? I don't understand why water has a delta positive and negative. That was
right. Okay, I can do
a bit of housekeeping before we move on to that. Just lots of students asking about a few generic questions about where and when to sign up and about the physics. So the physics, anyone with an Ultimate Guide subscription, as I said, there's two types of subscription. Rich has already gone through this. Starter Guide is the videos only. Ultimate Guide is the videos with all the extra help. Ask us questions, join the web classes. And yeah, if you do physics, you get the physics course included if you're an Ultimate Guide student. So basically, if you have any sort of questions, you're buying into us as a teacher. With the Ultimate Guide students, we'll help you out as much as possible. Starter Guide is only the video. So if you just want to use it as a learning resource, like an awesome digital textbook, then you can knock yourself out and go for it. But you have to study independently. Any other questions on that? Do you have to put in your card details to try it free? Yes, you've got to start the subscription with the try it free coupons. There's zero payment. And if you unsubscribe during the first month, if you decide not to continue, that's totally fine. You won't get charged anything if you do that, but you do need to put your details in on the sign up. So yeah, I think that was all the major questions. I've tidied off from the course. Yes, so Ronnie is also banging out comments as well. So I think that was the only chemistry question that I've seen so far about water, delta positive, delta negative. Also very important for A-level biology.
Yes, absolutely. Polar water, there's like huge questions they can ask on that, aren't there, in A-level biology? So there's a nice bit of crossover there. Cool. So I will answer that question, delta positive, delta negative, but I think just for everyone, as I said, I'm looking at giving you some tips on, you know, if you're starting year 12, and these are the things that I recommend that you do. Okay. So what I'm going to do is I am going to share screen again, but this time I'm going to bring up my, my iPad. It'll probably tell me to update it because I never do. Oh, it hasn't. There we go. Okay, so in terms of year 12 then, okay, this is what I'll do. These are my top tips. So if you're just starting, all right, for year 12, then this is what you need to do. So your year 12 starter for chemistry. Now, the first thing I would do, okay, is download your latest specification. Like I said, it's a pretty pants read, okay? It's not bedtime reading, it's not leisure reading, but you do need it, okay? You don't need the entire thing, but the content part of it, really, really important. So get that. You can download that obviously through us, but you can just type in A-level chemistry, AQA, then it'll probably be the first or second link that comes up there. So you definitely need that. They may give it you in school or college too. Now, organization, okay? Now, any year 13 student will tell you that you need to be organized. Maybe get yourself a folder with some dividers in it because there's very distinct sections in chemistry. Everything's interlinked, but you need to keep them nice and separate and nice and neat, ready for you to revise. Because you know what? I've been teaching for 15 years, right? Most students every year, no matter how much I say it, get to revise and they spend the first couple of weeks of revision just sorting their notes out. And that's no good. You don't want to be doing that. That's not revising. You need to be organized as you go along. Now, you know what? I'm pretty terrible at organization as well. So what I recommend to a lot of my students, or recommended to a lot of my students, is just get an exercise book. Get a massive A4 exercise book and write your notes in there. You know what? That's perfect, actually. If you're not using our skeleton notes, then you can just get a massive A4 book and everything will be in order for you. You don't need to organize it because the pages are fixed. So maybe a book, okay? So that's really, really good advice. That if you're not very organized, get yourself a massive A4 pad, or lever arch bound thing or something like that, okay? So you don't have to organize your paperwork. So in terms of the chemistry though, okay, these are the top things which you're going to be carrying on through from GCSE. Now, you've obviously, you've enjoyed your GCSE chemistry. You should know quite a bit about that. So these are the things, okay? So know your periodic table. You are looking at trends in the periodic table, okay? So when it comes to reactivity, when it comes to atomic number and how it's electron shells and so on and so forth, all that is going to be used year GCSE. Look at that for a starter for number one. Number two, I would say bonding. Bonding's a massive section in A-level chemistry in the first year. It's really important. You know what? Between you and me, there's not a massive amount of difference in what you actually learn about bonding. So with ionic bonding, with your covalent bonding, and with, of course, your metallic bonding, all right? So those three are really important. The only difference is your explanations of those and your descriptions of those types of bonding are a bit more in depth. We're using a lot different terminology, the correct terminology in order to describe those. But you know what? The basic principles, the stuff you learn at GCSE, it's exactly the same. Nothing's changed. Bonding hasn't changed between GCSE and A-level. It's just we're explaining it more precisely now at A-level. Next up, third one, rates of reaction. You will have done that. You are doing it again. But again, like I said about bonding, we're looking at it in more detail. We're going to look at collision theory. We're going to look at the factors that affect rates of reaction, which you should already know from GCSE, or at least remember, hazily remember. Okay, but rates of reaction is another big section that you've already covered, which will be tipping over into A-level chemistry. So rates of reaction, really important. Massive one now, so I'm going to write it massive. Mole calculations. Everyone loves a good mole calculation, okay? Now, you will have done some in a GCSE, all right? Be prepared to do a lot more. That is the understatement of the century, okay? So you saw the size, actually, of that mole calculation, amount of a substance section, when I showed you the course. But mole calculations, any notes you've gotten out from GCSE, keep them handy, because you're going to be using it a lot. And that is one thing, okay, that I stress you really get to grips with. You can't start this too early, okay? You say, Seb, mole calculations are your nightmare. You know what, Seb? We're here to help, my friends, okay? I will guide you through. So, you know, there's only 2 or 3 equations you need to know, but it's how you apply them in the questions and the way they put the questions that can make them very hard. But trust me, you know, I'm not a mathematician. Ronnie will tell you, all right? But you know, throughout my career, I've just figured out the easiest way to do stuff because I'm a little bit simple sometimes. So I need to work out the easiest way to do things, the simplest method, and that's how I'm going to teach you how to do it, okay? So not to say you're all as simple as me, but hey, don't we all want to know the easiest way, all right? So last one, I will say Redox. Anybody know what Redox stands for? Or oil rig? Anybody on the comments?
Well, I remember it from my A-level chemistry back in the day.
Oh yeah, you can't oil rigs. You know what? I can sit doing a tutorial. When I was stood in front of a class, you know, I'm doing a calculation or looking for reducing agents or oxidizing agents. The whole time it's just oil rig going around in my head. Yeah, reduction, oxidation. Yeah, oxidation is loss, reduction is gain. Spot on. Yes, we're talking about electrons. You're going to be doing bucket loads of redox in your AS chemistry, and even more in your second year, looking at electrochemistry and stuff like that. So just make sure you know these 5 things, I would say, are your most important things going on into year 12. Okay. So has anybody got any particular worries or questions going on to year 12? Anybody on the chat that's going into year 13? Maybe they want to offer up some advice maybe to year 12 students who are just starting this week?
We had a question from, is it Iklil, who asked, do you need to learn the whole periodic table? I gave my answer, but I thought I'd pass it on to the chemistry wizard to give you a full answer to that.
Wow, that would be something else if we had to learn the whole periodic table. No, we don't have to learn the entire periodic table. Just know how it works. So you know that all the elements are in order of atomic number. You need to know what those 2 numbers are. We got our atomic number, and we've got our molecular mass, or our relative atomic mass, or our mass number in there. Okay, if you know the basic structure of protons, neutrons, and electrons, and how electron structure is linked to the groups and the periods in the periodic table, then you know what? All that stuff in GCSE, fine. You do not, I repeat, do not need to know the entire periodic table. Okay, you've got that in your exam as well. You do get a periodic table in your exam amongst other bits of data, so you'll never have to remember it. To be fair, you use it so much, you probably remember most of the atomic numbers and mass numbers of the elements that you use. So
yeah, I remember even, you know, just from the ingrained in my head from A-level chemistry were some of the ones you use all the time, you know, lots of the group 1, group 2, and the stuff that you come across all the time. It's well worth just being there, you just knowing what their atomic masses are, or maybe what the really common isotopes are. Chlorine's got 2 really common isotopes and things like that. You'll just, you won't find that you need to go out your way to learn them because you'll just be using them so often. You're just gonna, if you're having to look up the atomic weight of carbon by the end of year 13, then you've probably got a bit of a problem.
We
had a question from Jay who said, I've heard of redox titrations, but I don't know what redox actually means. So yeah, it's to do with, in fact, I'll let Richard answer. He's the chemist. I'm definitely not the person. There's a little bit of redox in biology A level, which is mostly in the respiration photosynthesis of that. And I'll let Rich explain sort of what the basic definition of that is.
Yeah, absolutely. I think, redox in terms of titrations, normally in titrations, we'd think about acids and bases, and you put an indicator in that changes color when you reach that equivalence point where they've neutralized. A redox titration is very much the same thing, but you get a reduction and oxidation reaction. So one thing's being reduced and one thing's being oxidized. One thing is gaining electrons and one thing is losing electrons. And what they do is they change color a lot of things when they do. So a lot of our transition metal ions change color when they change oxidation state. So when that reaction happens, you get a change in color, and that's your end point to a redox titration. I think in each specification, there are 2 very specific ones you need to know, iron and permanganate. And I think another one is involving dichromate. I can't remember right off the top of my head right now, but there are 2 that you need to know. But don't worry, I'm going to be talking you through them on the course. So that's all good. Mo, some good advice from Mo there. Expose yourself to questions early, learn the tips and tricks. Most of the time, the examples repeat many questions and they do use the same style. You're right there, Mo. I got to admit, I was really mean when I was teaching in college. First thing I used to do once we'd done the first topic, like basically as many exam paper questions as I could find on that topic, and you'd be doing them. And that'd be like your second week. So just expose yourself to questions early. And that's what we're here to do as well, is give you all that insight into the exams, because like I said, knowing your stuff is one thing, learning how to sit that exam is another. So the sooner you can do A-level exam questions, the better. Awesome advice, Mo. Thank you very much, mate. So that's year 12, and I think we got some year 13s in now. We got some people just starting this week in year 13. So what we'll do is we will take some advice on year 13, and then we will look at any specific questions. I haven't forgotten about that one, about the polar water, folks. So moving forward in year 13. Now, there are certain topics which are going to come back to haunt you in year 13, ladies and gentlemen. Okay, Sarah, okay, very excited about going into year 13, and I don't blame you. So first one, I would say enthalpy and Hess. Now, you did enthalpy of combustion, enthalpy of formation, and all that sort of stuff, and Hess's law, of course, in your first year. We're going to use that, and we're going to apply it to something else called lattice enthalpy. Okay, so that is the enthalpy of salts and looking at how they dissolve. We're also looking at these things called Born-Haber cycles or Born-Haber cycles, which basically are more complex version of Hess. All right, they look really complex, but again, I'm no mathematical genius. I like setting things up in a way that's easy to figure out. So I've shown you on the course the easiest way to go about those. So that's where enthalpy and Hess are going to draw in on year 13. Only 3 more. KC. You will have done that during equilibrium, all right? When you looked at Le Chatelier's and then you started quantifying it using the equilibrium constant, Kc. This time in year 13, you'll be looking at Kp. So the C in the first one stands for concentration, and the P in the second one stands for pressure. A little more involved, but the equation is exactly the same, okay? But this time you're dealing with partial pressures instead of concentration. So if you can remember the expression for Kc, then you can remember the expression for Kp. Well, you already know it. So you're halfway there, folks, okay? Carl, you already started Kp. That's good going, Sarah. So yeah, you can see how it's a little more involved, looking at mole fractions and working out partial pressures and stuff. But all the tutorials are up there to help you in the chem course, all right? 3rd out of 4, as I mentioned just previously, okay, redox and half equations. Oops. Redox and half equations, hugely important, all right? Loads and loads of redox in your inorganic chemistry and physical chemistry when it comes to A-level, all right? So your year 2. That leads on to electrochemistry. So you'll be looking at cells and using half equations to figure out, is a reaction viable or not? Will this be reduced and will this be oxidized, and so on and so forth? So, you'll be using those tips and tricks you learned about redox in AS or your first year, and you will be applying them in the second year. And of course, as we've just mentioned, actually, redox titrations. You'll be doing a couple of those bad boys in year 13 as well. All right. So redox, really, really important. Seb, we didn't do pressure, concentration, and temperature in high school. With respect to what, Seb? I'll come back to that. And if you answer me that, what do you mean? Okay, what do you mean?
Rich, I thought maybe that was just that maybe you're covering topics that you're sort of repeating topics that you're doing at GCSE, but obviously it's not just you're not just redoing the GCSE. You go into a lot more detail during.
Oh yeah, for sure. Yeah, it's
so there are lots of things that you'll have done before you'll be familiar with, but it will probably be insanely complicated compared to what you did before.
Yeah, that's it. I mean, think of GCSE like a part truth. All right. So it's like, okay, it's kind of like this, but then when you get to A-level, it's like, it's actually like this. So, they're topics that you've covered before, but, don't worry. Nobody's going to assume that you know everything from GCSE. All right. We're just saying that these things should be familiar to you, or these topics should be familiar to you, at least the titles of them, when you get into AS. Okay. Number 4, 4th one. Now, massive one here. This is the most important one. Organic chemistry. Now, you have learned excuse my French, a shitload of organic chemistry at AS. Loads and loads of stuff on alkanes, alkenes, alcohols, aldehydes and ketones, carboxylic acids, halogenoalkanes, maybe even some amines and nitriles, depending on your exam board. You know what? Your teacher is going to assume that you know all of that moving forward, because there's another part to organic chemistry, like chapter 2, if you like, that you're going to have to learn and apply. So that mind map maybe of reactions you've already got, then that's just going to get bigger. All right. So make sure you've got that first year organic chemistry nailed down. You know it inside out, because there's no way you're going to learn it all when you get to the end of year 2. Okay. So make sure you've got that boxed off. Get yourself a summary, build yourself a mind map of all those different reactions from the first year, and make sure that you know it going into the second year. Okay. Gosh, what are you putting to me, mate?
Okay, I was going to just say, the question was, how much more difficult is A2 compared to AS for chemistry?
It's a mixed bag. I would say the redox gets quite tough. Okay, but I think if you've got a handle on, how redox works, it's not so bad. But it's the volume of other things as well that can be tricky. You're going to do a lot on transition metals, and there's lots of learning of colors and of complexes and of oxidation states and things. So that's quite tough. But then there's things like the enthalpy and Hess that I mentioned here, and the KC and KP. They're not so bad. Okay, they're not so bad at all. Like, the calculations don't get any harder, but I would say the redox and the transition metals, they do get harder. The organic chemistry, it's no more difficult. There's just more of it. Okay, so it's like you've done half of it in year 1, the other half is awaiting you in year 2. So there are a couple of topics which are tough, but I would say the rest of it is just you're adding to what you've already learned in the first year. So where are we going? Other things I was going to say. You know what? I might not write all these down, but other bits of advice going into year 13. All right. I would say keep in touch with year 1. In fact, you know what? I'm going to get rid of this. I'm going to talk to the screen a little bit. I'm probably a nice shade of pink right now, actually, aren't I? Because I'm in a very hot room. Are we looking at you, Rich? Or are we looking at me or what? Here we go. Sorry.
I can see you, mate.
I got a bit confused. So yeah, going into year 13, stay in touch with your year 12 stuff. All right. So make sure you've got all your year 12 notes. I would maybe even summarize them now. Keep maybe a 1-page summary for each section in the back of your folder. And you can reference that if you ever need to when you're in class. But equally, come to the webinars, because we'll be doing year 1, 6 till 7, and then year 2, 7 till 8. So as you go through your year 2, you can be dipping into the year 1 tutorials as you see fit, those web classes, right? And you can top up on what you've already learned that way. Work backwards in your topics. Okay, so when your teacher says to you, all right, well, we're doing electrochemistry next week, go back and check out all the redox stuff. Or we're doing the chemistry of aldehydes and ketones a bit more this week, go back and check out what you did last year in them. So do work backwards. Okay, and those practicals, lots of specified practicals. And as Rich was saying yesterday about the biology, a decent chunk of your exam, I think it's 15%, is going to be based on the practicals that are specified in that specification. They're slightly different for each exam board, but don't worry, we've got those boxed off. They're the ones that they can ask you questions on in the exam paper. All right, they're the only ones they can ask you questions on in the exam paper. So doing them in class, pay massive attention to them, but equally know how they work, know how, and have a go of exam questions based on those practicals, because they are definitely going to come up, because there's no coursework for you guys anymore. You have to test the practical side somehow, and that's through exam questions. So make sure you nail those down as well, folks. Okay. So those are my top tips for you guys going into year 13. Has anybody got any questions about year 13? I know you've already asked, like, is it much harder than year 12? Anything like that?
I've just been going through comments. No direct sort of year 13 specific related stuff. Just a few questions about general sort of housemate, like the physics, and just again that Ronnie's going to be doing physics A-level herself this year. She's going to do the exam in quotes, for fun, basically. And so she's going to be helping guide students through and training students with live classes and things throughout the year. It's not going to be a paid for course. It's only for students who join us with the Ultimate Guide. So Ronnie's going to be just sort of doing that as and when she wants to help guide you through. So anyone doing physics as well, you basically get as a bonus if you get the Ultimate Guide. I think that was the only other questions that I can see there. Yeah, with Ronnie and myself are handling the chat, so I think we're pretty much good to go.
Cool. Do you remember who was it asked about the delta positive, delta negative?
Yeah, I think it might have been Sebastian, but I'm not 100% sure. I'll find a name for you.
No, that's all right. It's all good. I mean, that's what basically I'm just going to go through that now. If you guys have got any
Sebastian, questions, I was right.
Awesome, good memory, mate. So what I'll do is I'll talk you through that. Okay. So where are we? Share screen.
A-level biologists, pay attention right now as well. This is pretty much, and well, I'll tell you afterwards, but it's water. The dipole nature of water is in the spec, and then biology will learn about how that contributes to large latent heat vaporization, high specific heat capacity, and a few other bits and pieces. But this is fundamental. If you understand this bit, you're going to understand why all those things. And if you can understand the underlying foundations to what causes something to happen, then usually you don't, it's called chunking in learning theory, is like often you can group that information, that understanding block just becomes one piece of information instead of just trying to learn all the different component parts in one go. If you understand how they link together, you just like chunk it into one block and it's way easier to remember in the exam. So over to you, Rich.
Yeah, that's awesome advice. Yeah, I think it's the same in chem as well. You build up, you start with the AS and you build up your knowledge of how atoms work and the electronic structure of atoms. And so much that links forward into, well, like stuff that we're doing now. So in your periodic table, obviously, you've got all your elements as a basic outline of the periodic table. Over here, you've got nitrogen, oxygen, and fluorine. Now, these three are highly electronegative. Okay, so they're not negative. Okay, they haven't got a fully negative charge, but when they're electronegative, what they're really good at is when you've got a covalent bond. Okay, so let's say between hydrogen and fluorine. When they're highly electronegative, what they do is they draw that bonding pair of electrons towards them. So this fluorine here has got a load of protons. It hasn't got many shells of electrons around it, so it draws those electrons towards it. So if I was to draw, say, another hydrogen and fluorine here, and I was to draw where those electrons are, most of the time they'd spend over here. Maybe go around the hydrogen every now and again, but they spend most of their time over round by the fluorine because the fluorine drags them towards it. So the hydrogen never really lets go, but like it's an unfair share, shall we say. Okay, so the fluorine is taking that pair of electrons and holding on to them, maybe letting hydrogen have them for the weekend or something like that. All right, so as a consequence, if that pair of electrons are spending most of their time over here and not over here, then what we have is known as a dipole. Okay, di meaning two, pole meaning kind of ends, if you like. So it's got two different ends. So when we've got something like water with hydrogen bonded to oxygen, bonded to hydrogen, again, we've got this shared pair of electrons, a covalent bond. Oxygen is again really highly electronegative. So these two pairs of electrons here, okay, they're going to spend most of their time around oxygen. And if the electrons are hanging out around oxygen, that's going to make it delta negative. Now, the delta means slightly, okay? So delta means a difference. Little delta there means a small difference. So it's slightly negative. And as a consequence, these are slightly positive. So what we get is a polar molecule. We've got a slightly positive end here, and we've got a slightly negative end here. So that's why water is polar, because it has this dipole in caused by a difference in electronegativity. All right, so that's our dipole in water. Now, moving that forward, what we can say, and you've probably come across some intermolecular forces, is that water, okay, has an intermolecular force between it, a really strong intermolecular force because of these dipoles. So that's delta negatives, and that's delta positive, okay? So our electrons there are spending most of their time around oxygen. When they get near another water molecule, okay, like so. The delta positive of the hydrogen and the delta negative of the oxygen are attracted to each other quite strongly, actually. So the positives and negatives attract each other. Now, this is an intermolecular force, so IMF, known as hydrogen bonding. You know, part of me wants to write to somebody and complain because it's not a bond. It's an intermolecular force, but it's caused by this huge difference in electronegativity, and the force between these is known as hydrogen bonding. And that's why water, even though it's such a small molecule, it's got these amazing properties. So it's got actually quite a high melting and boiling point for its size, okay? Obviously melts at 0 and boils at 100. That's quite high for a tiny molecule like this. It causes surface tension on water. So a little bit of biology, Rich. You get those pond skaters on the top of the water and you see that surface tension, or maybe at the top of a really full glass, you can see that lip. That's because of the hydrogen bonding between the polar molecules of water. And I would say more importantly, sorry, Rich, is when you're doing titrations, if you remember titrations, and you get your meniscus like this in your pipette or in your burette, that's caused by hydrogen bonding as well. It's attracting to the inside of the glass, okay, and moving up the glass. That's what it's trying to do anyway, and causing that meniscus. So polar water and polar molecules, I mean, that has a huge impact on the physical chemistry of these compounds. We do get into that in the bonding as well. So once we've done bonding, we look at intermolecular forces, and this is just one of them. But I've rambled on a bit here, but yes, delta positive means slightly positive because its electrons have been lost to the oxygen. Oxygen is slightly negative because it's hogging those electrons, and they spend, most of their time over there. All right. So a little bit of chem there. Anybody else got any questions?
Well, just a quick follow-up question from, I think it was also Sebastian, just saying, do you need to know not why nitrogen, oxygen, or fluorine are highly electronegative? Is it just because they're stronger electrostatic pull to the nucleus? I sort of know the answer, but I'll hand it back to you. It's to do with their group in the periodic table, right? And how much electron shielding is going on, and how many paired and unpaired electrons there are. But don't take my word for it. Ask Rich.
Yeah, 100%, boss, 100%. So what we've got is we see a trend in the periodic table. The further to the right you go, the more electronegative things get. The further up you go, the more electronegative things get. We're not counting group 8 because they don't make covalent bonds, but these three are the most electronegative. Why? Because they have a high effective charge on the nucleus. Now, I know there's other elements in the periodic table that have more protons in there, but because these are in the top right, they haven't got many shells of electrons. So nitrogen, we've got 7 protons, but it's only got 2 shells. You know, oxygen's got 8 electrons, it's got 2 shells. Fluorine has got 9 and it's got 2 shells. So when it's attracting other electrons towards them, okay, this has a high effective charge, because what happens is if we add another shell of electrons, so the one below nitrogen down here, then that is weaker attraction because this causes shielding. It stops the electron being dragged towards it because of the extra shielding of those electrons it's got in the atom. So tiny atoms, lots of protons, that's what makes things electronegative in layman's terms. Yeah, so tiny atoms, lots of electrons.
One other question that came up was from Mr. Gray, who said, how similar are the exam boards for the sciences? I said, my ballpark answer is 75, 80% overlap between AQA and OCR, and EdXL is a little bit more different, but they're broadly speaking very, very similar, but just little tweaks. More it's the exam wording and the tiny details that you need to know, which are slightly different. But water, this example that we've just been looking at, the dipole nature of water in a biology context, basically you'll need to know the major basics, and some go into more details on latent heat vaporization, some go into more detail on surface tension, but the underlying mechanics of what's going on and why is pretty much the same. I don't know about Kim though, Rich?
Yeah, absolutely. I mean, the underlying science, I would say 95% exactly the same. You know, we're talking about, chemistry doesn't change depending on what exam board you do. But like you say, it's the terminology they want you to use in the exams that's different. It's the examples in chemistry that are different. I mean, I was talking about transition metals before. And there are, numerous ones to choose from. Depending on the example, they want you to know different examples and the different colors of them. So that's the major difference, but all of them do transition metals. So like you say, it's the slight differences within the topics, but actually the topics that in chemistry, they're all the same. It's just some go into more detail on one topic than another and vice versa. But, I think the AS and the A2, the split, it's like they've sat down together and all agreed on it. So there's a lot of crossover in chemistry, but it's examples and practicals that are slightly different. That's the main thing. So anybody got any other questions on chemistry, maybe even on the course and stuff? I know Rich and Ronnie have been doing a sterling job on the chat. I'll get rid of this. Now I'll bring it back. If you've got another chemistry question, folks, feel free to test me. I don't mind being tested. It's all good.
I haven't seen any chemistry specific questions on the YouTube chat. We've just been lots of questioning. In fact, lots of good back and forth between students who've used the course already, cool. And students who have, either thinking about it or maybe used it just a little bit. And lots of just back and forth. I've been not doing very much. Mo's been doing a great job replying to people, and other students have just said that, how they've used it when they started using it and what their grade improvements are. We had a question, how many of our students get A stars? We're doing all the data analysis. So the results day competition is now closed. If you do want to submit your results, the link on the website is still there on the Tailored Tutors. I think it's like in the menu, you'll find the results day competition. If you want to just tell us what results you got, we can add that. We can look at how much of the course you've done from last year, and then we can do some sort of manipulations or calculations on how much of the course did you use or consume versus how much your grade changed and what grades you got on the end of it. So we're going to do all of that, and we will probably maybe we'll do that before the end of the month. We'll do a YouTube live, just sort of our results analysis. That's maybe a good idea that we can do. So we can give you some idea of like, yes, if you put the time in, if you complete as much of the course as you can, then how much you're expected to improve. Obviously, the more you put in, the more you're going to get out from it. We can just promise from our end that the things that we're going to teach you are like laser guided, bullet point targeted for the exam, so that you're not wasting your time. The hours you spend with us are sort of maximum output. But I'd say in terms of what else have I seen? Any other questions that are coming? Where can you get the package? The package is from the Tailored Tutors website, tailoredtutors.co.uk/subscriptions. Try it free. Don't pay for your first month. Try it free as a coupon, and you're going to get your first payment basically absolutely gratis.
We got Movid on there asking about shapes of molecules. Shape of molecule has like lone pairs that are not in the examples. For example, we know two bonding pairs, two lone pairs is V-shaped. Sometimes you come across molecules that don't have a set name. They have more lone pairs than usual. How do we name them? Basically, you don't. I don't think they won't in any example. They won't give you. They'll give you an unknown molecule, maybe a substance that you've not come across before, but guaranteed it will fit with one of the set shapes and bond angles that you've already been given. So whether it's tetrahedral, trigonal planar, trigonal pyramidal, octahedral, trigonal bipyramidal, it will fit into one of those categories. You just have to figure out which one it is. You won't get anything with three lone pairs and one bonding pair, for example. Okay, that won't come up because it's not in one of the set shapes. Okay, so that's my advice on that. You won't get given that in an exam, 100%. Even if school have given you one, they're just being mean. Ignore them. Okay, so in the exam, you won't get anything that doesn't fit into one of those categories you've already had. Okay. So somebody talk about self-study. Okay. Would you say it's doable, Rich, if you wanted to do it on your own?
Definitely students have done it in the past. And I would normally say that they need, it takes a huge amount of organization and sort of dedication and organizing your time and putting the work in. We have had students, I've had homeschooled students. In fact, when I started tutoring, one of my first major gigs, I was doing GCSE science to a student who had been expelled. And I was teaching his biology, chemistry, and physics GCSE. And as a result, I was like, oh, this really is possible. Really, I only had him for like half the amount of time that you would have done if he was in school. And it's like, okay, that would kind of open my eyes to the whole thing. It's like, oh, actually, there's loads of ways that this can be done a bit more effectively. It is difficult. On that said, it is really difficult. So take it. I mean, what I'd suggest is that you book a time to have a chat with us in the subjects you're thinking about doing. You're going to need to find an external examination center because we can't enter you for the exams. You need to find someone that's going to do that for you. You're also in
local college will let you do that.
You're going to have to do the practical skills as well. So the practical skills are mandatory. You have to complete them, do a logbook. You don't get assessed for them. But if you don't do them, in theory, you cannot pass. So there's details like that to be figured out. And also what I've suggested to some students who have done it completely self-study using the Ultimate Guide is that they maybe check in with a physical tutor maybe once a month or when they think they need it, just so that they can have that person hold them accountable and help them plan the year and take them through the entire year. Because sometimes there will be, you're going to need probably more support if you're using us entirely to teach you the course than if you're supplementing what you're doing at school. That said, we have the number of students that have told me that they've stopped going to classes and only used my course to teach them their A levels. I mean, we're talking many tens, 50 plus students have said that they, if their teacher was particular, they didn't get on with them or they didn't find their lessons effective. Often students will end up in a position where they study the tailored tutors materials at home before the lesson. They go to the lesson and they literally learn nothing new. They just see it's a waste of time. I do not advocate skipping cool classes whatsoever, but I know that lots of students do it. It's a fact of life. So I would say that it can be done. But you probably just need to make sure that you have a bit of a special strategy and you're really organized with your approach to the exams.
Yeah, for sure. I think Melissa was just saying on there that she hasn't done any chemistry in a year. You're going to pick up AS chemistry instead of English. That's a big change there, Melissa. But you know what? We haven't assumed anything in the course, okay? Like I was mentioning GCSE before, they're topics from GCSE that we're building on, but I'm not assumed any knowledge in the course whatsoever. So say, if you're doing AQA, OCR, Red Excel, those first few topics, they run through all the basics with you, okay? Basic atomic structure, all the things that you need to know from GCSE before moving on into the A level. So if you haven't done it for a year, that's cool. That's fine. You look at it with a fresh pair of eyes and hopefully it'll all make sense to you. But good on you dropping English and picking up chemistry. Go science.
Yeah, definitely. Jay just added that he's doing self-study after taking the wrong A levels. He's done lots of research. And yeah, absolutely. Just reaffirming that we have to find somewhere to enter you for the exam, to be your examination center is the correct technical term, and then to do the practicals and all the bits and pieces like that.
Yeah, I think that would be the biggest thing. I mean, the practicals in biology and chemistry just so important. I mean, there's no substitute for actually doing them. And unfortunately, that's the one thing we can't do with you guys. I'd love to do a practical with you all. I get like 500 students in a massive lecture theatre once a week and do prac, but it's not going to happen, is it? So although I am in talks with my local college actually about recording some live practical demos and stuff like that. So I'm going to see them, just for your info, Rich. I'm going to see them on Friday.
Oh, awesome. That's going to be great. It's news to me. And I just say also that when we could definitely do it. My labs at university, when I was studying university, especially first year biology, we had, I don't know, 200-300 students, because everyone has to do the same first year. If you apply to do genetics, you do the same first year. If you apply to do ecology, everyone has to have like a consistent foundation to which to build on in degree. And so our practical labs had benches for 80. I think there were 80 people, and then each bench had a TV screen, and then there was a little filming studio at the back of the lab with a full camera setup studio. So the professor would go into the lab and then demonstrate to the camera, and then everyone would have a like really clear view, like zoomed in focus of the practical step by step. And even we could maybe do them in stages, Rich, and you could have like each stage where you could pause and stop, because being able to rewatch that, demonstrations are great. You can ask questions, but you can't go back and rewind. So maybe there's definitely excellent. I know I was talking to a school in South London when I went to go visit them in the spring, and they have cameras set up in their school labs, and they said that they would invite me back to do various biology practicals there if we thought it was something that we could do in the future. So yeah, really lots of areas for development, although we can't promise any of that for this year because we are maxed out right now.
Yeah, absolutely. So yeah, I mean, it's always that thing in the questions in the exam. Some exam boards do and some exam boards don't. Like, Dave and Susan were doing an enzyme prac, and it's like, they tell you the story that goes with it, but if you can physically see it and watch it happening, like you say, pause and rewind and do it, then that's going to be awesome. But yeah, we need to get other stuff sorted for you guys first. But you know what? I'm going to get that done by the end of the year. I'm convinced, because I think it's so important. So I'll get that done. Who was asking about medicine? Movid asking about BMAT and UK CAT, and Mo's absolutely right. Mo and our friend Davina, I don't think she's in the chat tonight. Is it the 9th? Davina said she was going to do a UK CAT course. I'm sure she said she was going to do it on September the 9th, Rich.
We can get the dates for that for sure, and we can certainly connect. Davina's one of our former students who was like super on it, and she's a great teacher too, and she's going to be doing some BMAT and UK CAT courses. Just herself, not directly affiliated with us, but we will more than happily put students through to that. It's something that we're looking at maybe adding in the future, providing, because we know lots of people doing biology, chemistry, maths, physics are going to do veterinary, dentistry, medicine. So it's something that we will look to do in the future. But in the meantime, we can definitely connect you to a really awesome source for stuff to study and practice for the UK CAT and BMAT.
Oh, there you go. Mo's just saying it's on the 28th of September. He's doing that now. Him and Davina are doing it. So that should be awesome. I think I'll probably tune into that as well, actually. I'm interested in that. Awesome. So everybody got any other questions, folks? You know what? I mean, anybody doing UCAS at the moment? I can maybe give you a bit of hints and tips on UCAS personal statements and all that.
I'd say I'm going to have to sign off fairly soon. I am doing some filming this afternoon. I'm filming of me for once, and not just my hand. I'm doing a little bit of. We're booked in with a videographer to do a little bit of shooting for a few bits and pieces for the website. So I don't want to be. I'm paying for his time, and he starts in 1 minute. So I don't want to be.
You go, boss.
Yeah,
I'm going to wrap up here soon anyway. I think, we kind of done this. I mean, unless anybody's got any other specific questions about the course or about chemistry. I know Ronnie's
the only thing I'll add to you before I disappear will just be that we're going to be setting up a student community, and it's basically already created, but we haven't invited anyone to it yet. So all TT paid users, or those of you using the Try It Free this month, we'll be sending out an email relatively soon. We don't like to email you too often, but sometimes there's essential updates we need to keep you in touch about. So there'll be a link to the TT student community where you guys, as students, it will be moderated, but you guys can ask each other questions and then answer each other's questions, and share resources. If you want to share some, if your teacher's giving you a nice multiple choice question, maybe you can pass that on to other students. It will be curated and monitored by us. We'll have admins in there, but it'll be a really nice community. Teaching someone else is the most effective way of consolidating your knowledge. So keep your eyes open for that. It will be a private Facebook group for TT users, and basically a little secret club of community that we can share information and help each other out.
Awesome. Yeah,
that's it from me. So I'll sign off and say goodbye for now. And I'll probably be online tomorrow with Ronnie's class, 8 o'clock as well. So I'll check in with you all then, those of you doing maths.
Awesome. Cheers, Rich. Take it easy, mate.
See ya.
Okay, so there's a lot of talk about UK CAT here, folks. Sarah, that's one I can answer. Are there any discounts to the price, or is it completely fixed? My parents wanted to pay $99 for the Ultimate Biochem and Maths, sharing between my brother and I. We don't advocate you sharing, but you know what? That is pretty heavily discounting, £99 for the 3 courses, considering they're $49 each, folks. So $99 is for the 3 courses. That's the ultimate guide for all 3. So that is it. But as myself and Rich were saying just before, Try It Free. You get your first month free. Okay. And if you don't like it within that first month, you can cancel it. And then you are, you're no longer subscribed, you're no longer on the course, okay? So you don't have to carry on by subscribing to that first free month. But that is $99. And you know what? It sounds like a lot of money every month, but if you're getting a personal tutor, I mean, I'm up north, right? Things are a little cheaper up here. I don't know, anything between £30 and £50 per hour for a tutor. Now, if you're paying £50 an hour for a tutor and you have them twice a month, that's 2 hours a month. That's £100. If you sign up for all 3 courses, so that's like having 3 tutors for 24/7 for the entire month for $99, rather than just 2 hours of one person sat in a room with you. And you know what? You can get to decide what you do on Tailored Tutors when you want to do it. You don't have to wait for that tutor to come to your house or go to them, and you end up doing what they want to do. You get that in school. What's the point of that? Change it up and come to us and think about, you know what? I can learn ionization energies at 4 o'clock in the morning, or I can do some biology at, I don't know, on my lunch break while I'm eating a sandwich and watching it on my phone. So that's the benefit of this, folks. And I think, you know what, loads cheaper than a private tutor, and you get loads more money for your money. And like I said, it's not that we've just given you something and say, yeah, get on with it. If you're on the Ultimate Guide, ask us questions. We're here to answer those questions. Okay. So, Mo, I can't stay any longer, Mo. That'd be awesome. You know what? We'll have a chat with Rich. I think if we get one set up for you guys to talk, I mean, you're doing the 28th, aren't you? But would you like to come in and do a session maybe next week on UK Cat? Is that all right, Mo? Ronnie, yeah, good point. If Sarah, if you and or your parents want to give us a call, then, and if you've got any concerns, you've got any questions, I mean, we've got FAQ on the website, then, you know, if that's not what you want to know, then that's cool. You give us a ring, you can speak to Rich, you can speak to Travis in the office, and any questions you've got, we're more than happy to answer. You know, we're just completely open about this, completely transparent. You know, we haven't got anything to hide. We just think it's a very good deal. That's all we think. Okay. Mo, that'd be perfect. Yeah, I'll speak to Rich. We'll get you in next week and we'll get you doing, I don't know, 10, 15 minutes on UK Cat or however long you want, buddy. Don't want to tread on yours and Davina's toes for the 28th of September. That's going to be an awesome event. But if you want to come in next week, that'd be awesome. So, good. Oh, thanks, Sarah. I know, and it's a bit of a sales pitch. I know. I'm sorry. I'm not a salesperson. I'm a chemistry teacher. But you know what? That's the biggest thing. I mean, I know, you know, it's money, isn't it? And not every student has their own money to do this. You need to speak to your parents, and parents have concerns. Okay, they want to know what they're paying for, so it's completely understandable. But please, you know, email us at office@taylortutors.co.uk. You can email me directly or at chemistry@taylortutors.co.uk, or you can ring and speak to Travis or anybody else in the office, and you know, they'll answer any questions you've got. Okay, so. Yes, Ronnie, final advertisement here, folks, before we sign off. Tomorrow, Ronnie, you are doing some maths, lots and lots and lots of maths. So any maths people out there, okay, then we are going to be, I say we, Ronnie is going to be guiding you through what to expect through your first and second year in A-level maths. Now, to say that Ronnie knows his stuff is a massive understatement, folks. Okay, I would say in terms of qualifications, all right, as far as the teacher's concerned, Ronnie, oh yeah. Ronnie's kind of up there above myself and Rich. I mean, we're good, but like Ronnie's up here. So make sure you're here tomorrow to ask Ronnie lots and lots of questions because she loves it. She loves her maths. So, right, folks. So look out. We'll make an announcement. We'll make sure that we get Mo and or Davina in next week to talk about UK Cat. Those of you that are interested, that would be super awesome. And tomorrow is the last one of the week. Sad face. So we got maths tomorrow. I think myself and Rich are going to be checking in for a little bit as well, just to see if some decent math skills can get rub off on us. But that's about it from me tonight, folks. Thank you for joining us. Again, if you think of any questions once we've signed off, then chemistry@taylortutors.co.uk. You can send me a message, you can send me an email on that, and I will get back to you. And if you're already signed into the course, you've got any questions, just leave a comment below the video. Okay, thank you very much, Sebastian. Really good to see you again. Take it easy, mate. Sarah, I will probably see you tomorrow. Oh, yeah, you didn't do it A-level, didn't do maths A-level? Well, we won't see you tomorrow then. But thank you very much, Sarah and Movid and everyone else for getting involved. Really appreciate it. And yeah, I'll bump into some of you maths types tomorrow. Good night, folks.